types of comparator. One is non-inverting comparator, another one is inverting comparator. Why the two differences? One place we will give the reference voltage. Another thing, some application has to be done. So where we are giving the input signal, which terminal we are giving the input signal, based on that it is classified as two. One is inverting comparator, another one is non-inverting comparator. Non-inverting comparator means input signal we will give it in the non-inverting terminal. Inverting comparator means input signal we will give it in the inverting terminal. Non-inverting comparator means the input signal we will give it in the non-inverting terminal. Inverting comparator, the input signal we will give it to the inverting terminal. Inverting terminal is negative, non-inverting terminal is positive. So wherever you may give the input signal, the output will switch between plus VSAT and minus VSAT. There is no change in that. The output will be switch between plus VSAT and minus VSAT based on the comparison. Any terminal you can give the reference voltage and any terminal you can give the input voltage. The comparison here is the positive terminal. So this you have to keep it in mind. You should not confuse. Positive terminal voltage should be greater than negative terminal to get plus VSAT as the output. Positive terminal voltage, when it becomes less than negative terminal, the output will be minus VSAT. So this is the condition of the output what we get it depending upon the input signal we provide. Here the input signal we are giving it to the positive terminals. Therefore this comparator is a non-inverting comparator. If in the next slide you can see the input signal. This is the input signal. We are giving it to the negative terminal. If we give it to the negative terminal of an op-amp, then it is an inverting comparator. Clear? Difference understood? What is inverting comparator, non-inverting comparator? Input signal which we have to compare. If we give it to the non-inverting input, then it is a non-inverting comparator. The input signal which we have to compare, if we give it to the non-inverting terminal, then if we give it to the inverting terminal, then it is called as inverting comparator. So next we will see the operation. So here the input signal is a varying signal. So we have considered an AC signal. And we are giving a reference voltage. Reference voltage we have given it in the inverting terminal. Input signal we have given it in the non-inverting terminal. So the voltage will be compared. Reference signal here we have given is a DC signal. Plus is connected to the circuit, minus is connected to ground. Therefore, it is a positive reference. Input signal, to show it is a varying signal, we have taken an AC signal. Reference signal, we have considered a DC. DC means a fixed voltage. So moisture level of the soil will keep a fixed voltage. But actually the soil moisture level will vary. The reference voltage we will keep a constant voltage. So the reference voltage we have kept it. So reference voltage here always we can tell it is, for example we'll tell the reference voltage we have kept is 3 volt. And input voltage sinusoidal, it is a varying signal. To show it is a varying signal, I'll tell this maximum is 5 volt, minimum is minus 5 volt.
Yay!
Who's talking? Anyone having any doubt? So varying signal, we are having a reference voltage. The reference, so reference voltage, what we are going to have is this color, you consider it as reference voltage. So reference voltage, what we are having is 3 volt. It is 3 volt. Reference voltage is fixed. So this side, I'll draw it reference voltage, we will take it as 3 volt. So this input signal, always remember in non-inverting comparator, this we are giving it the input signal, we are giving it to the positive terminal of an op-amp. Positive terminal, non-inverting comparator means the varying signal we are giving it to positive terminal. And here there is reference voltage. Reference voltage, consider it as 3 volt, for example. And here maximum is 5 volt. Minimum we will consider as minus 5 volt. Minimum we will consider as minus 5 volt. So when the input voltage becomes greater than V reference, here it is 3 volt. When the input becomes greater than 3 volt, what will be the output of an comparator? Can someone tell? Input voltage becomes greater than 3 volt. This region. Greater than 3 volt. What will be the output of the comparator? Output of op-amp. This input we are giving it to the positive terminal. Reference voltage we are giving it in the negative terminal. So when the positive voltage becomes greater than negative voltage, what will be the output? What will be the output? When positive becomes greater than negative. Can someone tell what is the output? When positive becomes greater than negative, what will be the output? When positive becomes greater than negative, the output will be plus Vsat. The output will be plus Vsat. And when it becomes less than reference voltage. So this region, when it comes less than reference voltage, the positive terminal voltage becomes less than the negative terminal voltage. When it becomes less, the output will become minus Vsat. The output will become minus Vsat. So this is the logic how the comparator works. Whatever may be the circuit, only you have to check it with the input and the reference. The next what circuit is given us, the reference voltage we have make it as negative. So last case we have considered 3 volt. Here consider it as minus 3 volt. So if it is minus 3 volt, any voltage, if the input voltage becomes greater than minus 3, so this voltage level, when the input voltage becomes greater than minus 3, the output will be plus Vsat. When the input voltage becomes less than minus 3, the output will become minus Vsat. So this is how a comparator circuit works. Any doubt in this? Understood the logic? How we will classify it as inverting comparator and non-inverting comparator? How we will classify it as inverting comparator, non-inverting comparator? Inverting comparator means giving the input signal in the inverting input. Giving the input signal which we have to compare. If we give it in the inverting input, then it is called as inverting comparator. And if we give the input signal which we have to compare in the non-inverting input, then it is a non-inverting comparator. So one terminal we will give the input signal, another terminal we will provide the reference signal. So for comparison, one terminal we have to provide the reference signal, another terminal it will be the input which we are going to sense it using sensor or any input, varying input what we are providing. Clear? So this is non-inverting comparator. Non-inverting comparator, input signal is given in non-inverting terminal, reference voltage we are giving it in inverting terminal, and the reference voltage what we are giving can be either positive or negative. If it is positive voltage, that level will be above 0. So here the level is above 0. Negative means it will be below 0. So whatever may be the reference, the comparison logic is only this two condition. Positive terminal voltage should be greater than negative terminal voltage. The output will be plus Vsat. If the positive is less than negative, then the output is minus Vsat. So this is an inverting comparator. Inverting comparator means input signal we are giving it to the inverting terminal and reference voltage. So how the reference voltage practically set is, we won't give the external DC supply. We will connect potentiometer between the power supply. So only this circuit, the reference voltage is given like this. If we have a potentiometer connected with the power supply, by that we will adjust the voltage at the reference. So here reference voltage is given in the non-inverting terminal. So this is reference voltage. So reference voltage actually we have given it in the reference voltage is given it in the positive terminal. This input signal which we are going to compare is given in the negative. So input signal when it becomes greater than V reference, when it becomes greater than V reference, actually negative terminal voltage is becoming greater. When negative terminal voltage becomes greater, output will be minus Vsat. And here after below this point, this is reference. Below this, the signal is less than V reference. The meaning is the negative terminal voltage is less than positive terminal voltage. That is, positive terminal voltage is greater than negative terminal voltage. Therefore, the output is plus Vsat. Similarly, the reference voltage can be either positive or negative. Here in this diagram, negative reference voltage is considered. So, but the comparison is same. Here the reference voltage is given in positive terminal. Signal what we have to compare is given in the negative terminal. Always positive terminal voltage should be high to get plus Vsat. When the positive terminal voltage becomes less than the negative terminal voltage, the output will become minus Vsat.